In this video, we're going to look at solving probability problems. We're going to look at working with everyday events involving probability, solving problems that involve probability, and solving problems that also involve the need for precision. The outcomes we're going to cover include solving a contextual problem that involves odds or probability. So here's our first problem. You work at a factory that makes CFLs, or compact fluorescent lights. You analyze a recent batch of a new type of bulb. Your analysis shows that the number of defective light bulbs in the batch is about 1 in 36. So the first question, we want to express the defect rate as a percent to 5 decimal places and also to the nearest percent. So the defect rate we said is 1 in 36. As a percent to 5 decimal places, be 1 divided by 36, multiply that by 100 units percent, and we get 2.77778%. To the nearest percent, we're going to round that. So 2.77778 is about 3%. Okay, your plant makes 1 million of the light bulbs. Using the two defect rates from part A, we want to calculate the potential number of defective light bulbs, and we want to determine what is the difference between the two results. Using the precise measurement, we take our defective percentage, 2.77778, which I have also turned into a decimal number, multiply that by 1 million, and we get 27,777.8, or about 27,778 bulbs that are defective out of the million. Using the rounded measurement, we take 1 million, multiply it by 3%, which I've again turned into a decimal, 0.03. So 1 million times 0.03 is 30,000 bulbs. The difference between the two is 30,000 for the rounded rate and 27,778 for the precise measurement, which is 2,222 bulbs. Now we want to look at which degree of precision do you think the manager of the factory would want to see, and explain your reasoning. Well, there's a difference of about 2,200 bulbs, a little bit more than 2,200 bulbs between the precise measurement and the rounded measurement. So that means if you use the rounded measurement, you're going to throw away about 2,200 additional bulbs. If there are 2,200 less defective bulbs, then the factory can earn more money off the sale of those bulbs. So the manager would likely prefer the more precise measurement, where there's 2,200 less bulbs to throw away. You'll often see examples like this, where our weather patterns and how we run our day based on weather is often based on probabilities due to previous days that have similar types of incoming weather conditions. So the owner of a paving company routinely checks weather forecasts to schedule jobs. Dry, sunny weather is the best for laying down asphalt. Below we have a 6-day forecast from a weather website. So you can see on Monday we have cloudy with sunny breaks. On Tuesday it looks like there's going to be rain. On Wednesday there's going to be isolated showers. Then on Thursday, Friday, and Saturday it's going to be sunny. So we have a few questions here. First, you might have noticed, I'll go back and show you again, that we have something on the on our weather report. It's called POP, which you can see right here. So our first question is, what does POP stand for? If you do ever watch the weather report, you'll often hear POP, or The actual term is probability of precipitation. And the probability of precipitation actually means what are the chances of it raining or snowing. Of course, in the winter it could be snowing out. And lastly, how can POP help the owner of the paving company? Well, the owner can't work in wet conditions. That's one of the problems he faces. So Tuesday and Wednesday, if he looks at the forecast, he may realize that it might not be very easy to get any work done. So on those days, if he wants to get any work done at all, he's probably going to want to check the weather report more frequently to see if there might be a possibility of some dry times during those days where the showers aren't ongoing. What would be the best days for paving during the week shown? Well, the best day is for Thursday, Friday, and Saturday because it was expected to be dry and sunny. Monday would also be a good day because there was sunny breaks expected, but he'd have to be careful because it did say that the POP, or probability of precipitation, is 40%. That means that 40% of days with similar weather conditions, there was some rain. So to summarize, by using probabilities, many types of problems can be analyzed and worked out. We looked at a couple of examples just now. And these probabilities might not be perfect. They might not be giving us a perfect view of what's going on, but they do give us good data in terms of decision making. And you can see in the second problem that the paving company owner likely would not get a whole lot of work done, would not expect a whole lot of work to be done on Tuesday or Wednesday, so he'd probably plan around that for the rest of the week.